yeah, we have a lot of empty space in the front, by the way. So folks in the back, I know you're taking notes, but it's going to be really far to take a picture from our pretty faces. So you can come closer. You can come closer.
Yeah, and thanks everyone for coming out. I know it's been 3 days of awesome talks, so I appreciate that you're all here.
Yeah. So let's get in, jump in. So before the content, let me quickly introduce myself. My name is Julio. I'm working at Gradle for a little while now. I'm leading the developer platform engineering team, which is basically the team that does internal developer platform at Gradle. So basically my team is building the developer productivity for a developer productivity company. No pressure. Previously I was working as an Android engineer in some large projects, including SoundCloud. I also worked at Autodesk and some other places back in Brazil, where I'm from. I am a big developer productivity enthusiast. So, as I said, leading the developer platform team also at SoundCloud before, interdisciplinary team, not only Android. So, I used to be an Android engineer. Nowadays, I call myself a developer productivity engineer. So, but I still love Android. That's why I'm here today. And I'm contributing to some open source repositories as well for productivity. So, for instance, Backstage. I'm not sure who heard of Backstage before? Yeah, CNCF project, the developer portal. Exactly. So I also do some web development. Don't throw apples or tomatoes at me. Yeah. What about you, Nelson?
Thanks. Yeah, so I'm Nelson. I am also previously an Android engineer at companies like SoundCloud.
Oh, wow.
Square, and I've also worked at some small startups. And I also maintain a couple of Gradle plugins that you may have also used, such as Flatable, which lets you easily scale your instrumentation tests on Firebase Test Lab. And I also maintain the Gradle Doctor, which gives you actionable insights for your build. So yeah, why did we give this intro? The point is, we see a lot of builds. We've seen a lot of Android builds, Gradle builds, Maven builds, from 10-person teams to 1,000+ teams. So we have a lot of experience. And one thing that we do, so on the solutions team, is we optimize and understand builds for our customers and our prospects. We also increase build stability, understanding failures, and then we preach developer productivity. Another part of our work that we do is improving the Gradle ecosystem. For example, when we see issues with plugins that our customers are using, we go and report those issues, and sometimes we fix them in open source plugins on GitHub. And we also meet with Google and JetBrains to help prioritize issues facing customers and bugs. Yeah, so that's the main thing of our work. So speaking of preaching developer productivity, which is obviously something we talk about every day, in Android development, a lot of times we're working on features, but there's also tech debt. And of course, there's a lot of different other things you can work on as an Android developer. But when you're working on tech debt, you can refactor code, and you can also improve the build. And of course, there's other things. And what I'm here to tell you is that slow builds are basically tech debt, but it always pays off to work on it, because builds take a lot of time. And if you spend any time improving your build, you're going to get that time back. Just as an example here, if your build has 60 seconds of waste, and you run 50 builds a day, and you have 50 developers on your team, that equals 42 hours of lost productivity per day, and that doesn't include lost focus. There's also a link here to our ROI calculator that allows you to calculate in monetary terms how much time, the time you save, translating that to dollars based on minutes and how much your salary is, if you're curious. But my point here is that fast builds matter. When you're wasting 42 hours per day, over 40, if you imagine a standard 40-hour work week, that's basically like hiring 5 new developers without paying them and without recruiting. So yeah, slow builds are tech debt, and it always pays off to work on it. And it's also easy to justify working on it because you can quantify the savings. So yeah, we're going to talk a lot about Gradle Enterprise here. I'm just putting up the link here. Before I dive into that, how many here have used a build scan? Okay, I see a lot of hands in the audience. That's good to see. And how many people here are Gradle Enterprise customers?
Yeah.
All right, awesome. We got a couple. You can try out build scans at scans.gradle.com. It's really easy. You run a build with --scan, And if you're not a Gradle Enterprise customer and you want to play around with Gradle Enterprise, we have a lot of open source partners on this website right here. For example, the Android X team has their own Gradle Enterprise instance that we host for them, as well as many other open source projects such as JetBrains, Kotlin, that is, and Spring. And we host open source Gradle Enterprise instances for them as a way of giving back to the community. So if you want to browse around the UI, check out build scans, check out the performance dashboards, feel free to browse that website right there. All right, so we're going to talk a lot about build caching during this talk, which is obviously one of our favorite topics. And before I get into that, let's discuss what exactly build caching is. So let's say you're running a Gradle build, and you have a Java compile task. Now, any task can be made cacheable, but I'm just going to use the Java compile as a simple example. The inputs to the Java compile task are source files, compiler arguments, dependencies. Obviously, there's many other things, but I'm just giving a simplified illustration here. And when you compile these things, what comes out is class files. The inputs that you see here, those are part of the cache key. And that cache key is what's used to look up the outputs of that task in the build cache. So anytime you have the same cache key, you can look up the same outputs. We're also going to talk a lot about cache misses here. So what is a cache miss exactly? It's when you expect a cache hit, but the cache key is different for whatever reason. The task outcome is still the same, but the cache key is different, so you can't look up that output that you expected to be the same. Thing is, only inputs that affect the outcome of the task should be tracked as inputs. So what does this look like in a build scan? If you're using build scans, even without Gradle Enterprise, you'll see this miss here in the UI that tells you that there was a cache miss, and then it was stored to the build cache. And then if you want to know why there was a build cache miss, you can use the task inputs comparison tool in Gradle Enterprise. I'm just showing a little video here of how you would select two builds to do an input comparison. To understand why there's a cache miss, you need to compare the build to the build that you expected to seed the build cache. And then when you do that comparison, as shown there, then you get this nice UI. And when you hover over these green and blue dots in the UI, tell you that there's a difference. And when you hover over that, it tells you, okay, this file had different contents. So I'm going to be using that UI a lot during these talk, so that's just one illustration there. So what are some common cache misses that we see with our customers? One would be build configuration differences. This came up with a customer recently. The incremental compilation, well, we saw this input difference to the Kotlin compile task, which said incremental compilation enabled. After looking at the different input options that were passed as Gradle properties, we saw with this customer that they had Kotlin.incremental set to false on CI and Kotlin.incremental set to true for local builds. Thing is, the incremental compilation has no effect on the outcome of the task, so it shouldn't actually be tracked as inputs. So yeah, while one way to fix the cache miss would be to set it to true, another way is to report it to JetBrains. Here's an issue that was filed where Kotlin incremental compilation should not be marked as an input to the task. Okay, diving into another common cache miss we see with customers. If you use the live literals feature in the Android Gradle plugin, I'm just going to show a little video of what that does. That lets you, on the fly, give you a preview of what your UI would look like when you adjust certain literal strings when you're using Jetpack Compose. The downside to this is that you will get this cache miss when you do a task input comparison on any compilation task. And when you hover over that file, it says there's a difference to that file, live literals analytics event kt.class. That file contains a fully qualified path, that is the entire path on the file system. It's written to the output of that file. That means if you run the build on a different machine or you run it on CI, you won't be able to get a cache hit when you run that same task locally. What's the fix? Well, the workaround, I should say, is to disable live literals. You can do that like this. But then, of course, you can't use that live preview feature. But yeah, we've also filed a bug with Google to let them know, and they're working on a fix for the live literals. Another one that we saw recently with customers was this cache miss with KSP. And it was happening on the plugin options. So yeah, another thing I want to illustrate is how to debug cache misses. So in this case, it's a value property, it's not a file. In the previous cache miss, we looked at the file, that live literals file, and we looked at it visually and compared it, and it had an absolute path. In this case, we're going to need to look at what this value property is. That's an input to the task. So in this case, it's on the KSP task JVM. Property is pluginoptions.asTaskInputArgs. How do you debug this? So you configure the task.with-type. In the do last part of that task, you grab the plugin options. You iterate through each plugin option, and then you get the task input arguments, which is a property on that plugin option, and you add that as a build scan custom value, and that's how you do that. You have to call root project. That's just a way, a thing about using custom values. But what does that do? That adds these as custom values in your build scan. So when you do that task input comparison, you'll get something like this. The key on the left side is the KSP option. On the right side is the value, what was actually being passed. And if you look at this, you see that this build was actually run during an experiment which had the timestamp as the name, the folder name. What you also see is that the fully qualified path to that file is part of that property that includes the username. And that means that if I'm running the build and Julio runs the build, we won't be able to get a cache hit. But what are we actually doing wrong here? We're following the directions straight from the Google documentation on how to provide the room schema as an argument. And if you go to this, we actually see that we're passing the relative path sensitivity. That is, we don't care about the absolute path to the file, we only care about the relative path to the file in our project. What that does is it ignores, for example, my username and that timestamp that was a folder name. And what you do is you take the room schema argument and you pass it to the KSP extension. Yeah, this is straight from the documentation. But yeah, we're still seeing this cache miss. So what's really going on here? Well, it turns out that this command line argument provider, which has the relative path, if you take a look into the KSP source code, KSP is actually maintained by Google. If you look at it, it takes all these command line argument providers and it passes them as a sub-plugin option to KSP. And what does that do? That actually, if you look at the code, sub-plugin options are considered as inputs. That takes the string value of them and adds them as inputs. So what's the fix? Change it to an internal sub-plugin option. So this was actually a fix that we did in Yaki on the solutions team did to the KSP. So you actually don't have to change anything in your code. As soon as this is released, all you have to do is upgrade KSP and then you won't have any more cache misses. All right, enough about build cache misses. How many of you use the configuration cache? All right, so we have about half of the people in the audience using the configuration cache. One thing we noticed quite often is configuration cache miss. This is a new exciting category of cache misses that we love. So yeah, this is actually a really common one that we saw. In your output, it says calculating task graph as the configuration cache cannot be reused because an input to the plugin changed. How do you debug this? So you might think, let's check the configuration cache report. Well, the configuration cache report says everything's great because there were no problems storing to the configuration cache. The issue is retrieving it from the configuration cache. So how do you actually debug this? You attach the debugger to the Gradle build process. You can do this by simply adding the -d org.gradle.debug equals true. And then you attach your debugger from your IDE to the Gradle build process. Then you can set breakpoints wherever you want in the Gradle code base. In this case, you can set a breakpoint in the configuration cache fingerprint writer and the configuration cache fingerprint checker. And then you can just print which files are changing by looking at the variables. And after doing this, we saw that this capped directory was being read at configuration time. Turns out, if you apply the capped plugin and you're using Gradle 8.1 or higher, you have a configuration cache miss. But it's only happening in Gradle 8.1 or higher. Why is that? Well, if you look at the release notes, you might have noticed that there are configuration inputs detection improvements. These are part of making the configuration cache stable in Gradle 8.1. And it now detects file collections being queried at configuration time. So what did we do? We filed a bug to capped. We said, hey, you're reading files at configuration time. And after some investigation, it turns out it's actually a bug with the Android Gradle plugin, reading lint outputs and registering the external apt Java output that I'm sure, of course, you are all super familiar with. Just kidding. And yeah, we really pushed them hard on this one to fix it. So there will be a patch release for the Android Gradle plugin 8.1. Hopefully it'll be fixed in 8.1.1. And if not, it'll be fixed in AGP 8.2. And then also, yeah, we gave this feedback also to the Gradle build tool team. They will also be working on a way to make this easier to debug by actually printing these files that are being used as inputs, so that you don't have to attach a debugger to the Gradle build process to know what's going on. With that, I'm going to hand it over to Julio to talk about a slightly different topic.
Yeah, I mean, cache misses is, I think the point is, you can have them everywhere, right? In your code, but also in third-party code, right? So with build scans, you have this visibility of, maybe I'm inheriting something that causes, some delay in the build and the compilation step or whatever it is, right? But Gradle Enterprise is not great only with regards to like caching things and making things faster. Well, now that we know, we fixed all the cache misses and we understood how the build times are distributed, what else can we do with Gradle Enterprise? So, let me give a step back here and ask, how many people here write tests? Nice. Most of the people. Nice. A few years ago in the RedCon, it wasn't like this, right? How many people here write UI tests or instrumented tests? How many people have flaky tests? Oh yeah, the same hands. Yeah, we also have flaky tests internally, right? So Gradle Enterprise can help a lot with that. How many people like their flaky tests? There's a person over there. Yeah, we can talk later. So yeah, Gradle Enterprise can help you proactively as well, right? Like flaky tests are a big problem, right? Flaky tests, no one introduces flaky tests on purpose, right? Most of the time, tests become flaky after the fact. And besides reacting to things, you also want to be able to also be proactive, right? And prevent things from happening and causing damage, right? One way we do this internally at Gradle is using the Gradle Enterprise API. So how many of you have heard of the Gradle Enterprise API? So Gradle Enterprise has an API you can actually query to extract data from your Gradle Enterprise instance, right? We have a few endpoints that are super interesting. You can get information about individual builds from your build scans. You can have information directly about the build cache, the hit ratio and whatnot. You can also get information about your test distribution nodes if you're sharding your tests in CI agents. These things are already available in the Gradle Enterprise API today. But on the latest version of Gradle Enterprise, we have a newcomer, and that's the Gradle Enterprise Test API. Ooh, what is the Test API? Woohoo! It's beta. So the Test API is going to give you information about tests, test outcomes, test flakiness, and that's really cool because you can bring that into other data pipelines and analyze it later and create some crazy automations or super cool integrations. So automate all the things and integrate all the things. So I'm going to share with you a few use cases that we actually built internally with the latest version of Gradle Enterprise using the test API that might be interesting to you to empower engineers in your team, yourself, or maybe even create reports for non-engineers in your company. So, you know, if your VP comes to you, your CTO comes to you and says, what are these flaky tests? You know, you can better answer them. And not only that, you're going to be able to answer questions like, are we more flaky today than we were 2 years ago? Or is there a specific team in my organization that has more flaky tests, or maybe some part of my infrastructure that's causing more flakiness? So I think that's a pretty interesting use case, right? And the Gradle Enterprise API can support you with that. Did you know?
I didn't know.
Yeah, there you go.
Tell me.
So yeah, what can you do with the Gradle Enterprise Test API? So you can retrieve test suites and test case details, filtering by a bunch of parameters. As I mentioned, right, by test container, so basically focusing on a specific test suite or a test case. You can filter out by test outcome. So for example, you want to see the rate of successful or failed test cases over time, but also flaky tests. And then you can also add tags, custom values, and much more. I'm not sure if you've heard of like tags before, but it's a way to actually mark your build scans with an arbitrary string. So that way you can split your build scans by team, or maybe by which CI agent they are running on, or maybe which CI engine they are running on, or maybe which day or which branch, whatever you want, right? It's up to you to organize your tags, and you can query them later to create your reports. So here's a little example of how the API looks like. You don't need to read super deeply what it is, but here you can see we're querying the API/test/containers endpoint here, and I'm passing a little star. So basically, give me all of the containers for tests that started from this date to that date, and they are flaky, right? And the Gradle Test API is going to return you only these build scans, only these test containers. So here in the example, you see I have 2 test containers. There are actually 2 test classes in this case, utils test, and their outcome distribution, right? How many of them passed, how many of them are flaky, how many of them failed, how many of them were not selected for predictive test selection if you have that feature enabled, and so on. You can also dig deeper into this, right? So let's say, you know, I want to take a look into actually utils test. Well, where's the flakiness coming from? Then we have another endpoint, that's the test cases endpoint. And now I specify the container to be that specific test suite, and I get the same information, but now drill down for the specific test case. So I can see that utilstest.toWebRepo HTTPS is quite flaky, actually, over this period of time. I have 8 flakes on that specific test case. And I also have 8 flakes on toWebRepo Git. So this parameterized test, there's something smelling here. So it's an easy way to actually prioritize what you're going to investigate first in the team, right? Or maybe which tests you want to take off your main pipeline to not block engineers because of flaky. So yeah, but flaky here, flaky test. What is actually a flaky test according to Gradle Enterprise? So, you know, a flaky test is a non-deterministic outcome. So it's a test that succeeds sometimes or fails sometimes within the scope of a single Gradle task, right? So when you run a single Gradle execution, you might instrument your test execution to retry, so maybe 1 time, 2 times, 3 times. And if the outcome is different, that's how Gradle Enterprise marks a test as flaky. So what are some cool use cases you can use the API for? So one of the things we did internally at Gradle that really helped us prevent flakiness from actually entering our repository is querying this API when you open a pull request. So imagine an engineer creates a pull request adding a new UI test to an application that we're building. What we do on our CI is that we're going to pick that new test on the diff, run it maybe 10 times, and check whether it always succeeds, whether it always fails, or if it succeeds or fails sometimes. And if it succeeds and fails sometimes, then we have an automation that will query the Gradle Enterprise API to actually tag that pull request. That pull request will then be rejected. Well, you have a flaky test. You're introducing a flaky test into the code base. So yeah, please take a look again before you do that. Yeah, you know, of course, you know, most of the times, no one introduces a flaky test on purpose, right? They become flaky over time. So it's also super interesting to use the Gradle Enterprise API to pull the data into another data pipeline, processing pipeline, right? That's also something we do internally. So you can bring the data from Gradle Enterprise into some sort of data lake that you have internally, for example, with Prometheus, Elasticsearch, or like draw dashboards with Grafana, and then create further integrations for when things become flaky later. So here I have an example of a Slack message. It's actually a Prometheus alert that we built that checks whether you have flakiness rate increase. So in this example here, you see the overall rate of flakiness increased by 5%. And by the way, these are the last pull requests that enter the repository that might be the culprits, right? So you have a direct link on your, in this case, it pops up on Slack for us. It's the direct link to actually go back and see, what is the cause of this flakiness? And then when that alert gets resolved, you can go back to sleep with no nightmares about flaky tests. Yeah, can I get some claps for that? Pretty cool, huh? Yeah, well, I mean, you can integrate the Gradle Enterprise API just like any other API with your Git repository in GitHub, but when I mention repository, it's also really cool that you can take insights from your repository structure as well. So that's some other use case that we've built. So internally at Gradle, we use TeamCity as our CI engine, and TeamCity checks out our repository before running the test. So we actually have in this structure of our repository and also the test execution in runtime. And we actually correlate these two things. So another thing that we do is a weekly report that we send to all of our engineering team, including our stakeholders that are not technical, with a distribution with the most common flaky tests on that week, right? And because we know that these are in Gradle Enterprise, we can directly put a button there to take you to see the build scans and look at the details individually, like, where did these tests come from? That's what I was looking for here. Yeah, but since we know also the module structure, because we have the Git repository checked out, we can also correlate these things into Gradle modules and say, not only you have these Gradle tests failing, but many of them, the top ones, are in this build cache controller module, right? So the team that's responsible for that can take a look. Well, last week we had 15 flaky tests on our modules. This week we have 19. Something is up with our infrastructure. Well, we also look into code snippets in our code base, right? As I said, we checked out the code. So you can see, when you ignore tests or you mark tests as broken, or if someone goes there and adds this, like, please retry this test 3 times, that will increase your overall test execution time to 3 times. We can also track these things. We do track these things at Gradle internally, and we keep that trend over time. So each individual message of this is actually not the output. It's an input to a further processing pipeline that actually looks at how this evolves over time. So are we ignoring more tests in the last 6 months? Are we ignoring less tests in the last 6 months? Are we actually doing a good job to bring the health of our repository to a better shape? And yeah, in the end of the day, it's all about ownership. And assigning that to teams is also really easy if you have a code owners file or if you have like a clear definition of your module structure with a modularized code base in Android, for example, to the different feature teams. And that's what we also do weekly at Gradle. So as you can see here, there's a link to the component to each team assignment. So it's really easy to see directly from our report which teams should have a flaky day to fix all the flaky tests, or which teams might be understaffed and didn't really take care of their infrastructure in the last few months because most of their tests became flaky, and now they're only building the Android app, but someone didn't look at the API and what's happening on the back end. Yeah, so the comprehensive report has been pretty useful for us internally as well to manage our own test flakiness at Gradle when building Gradle Enterprise. Another way you can correlate your repository with the actual tests is by identifying issues earlier. So I'm going to show you like a very colorful slide now. This is a dashboard we've built based on Prometheus, pulling the data from Gradle Enterprise. So here you can see each column on this table is a commit that landed on our main branch, and each row is one of our integration tests, right? So it gets really easy to see for green rows, well, these are very healthy tests. For rows that have the blue color, they are skip tests. So what's up with these skip tests? For how long are they skipped, and when did they get skipped? But more interestingly, we also get the flaky outcome. So it's very simple to see when a test started becoming flaky, which commit landed on main, which date exactly, and who was the author of that commit that actually might have introduced that flakiness. Not only that, like when was the time where that flakiness went across the threshold and started failing more often? So this is also like pretty useful for us, right? You can see on the top, we even built some extra filtering capabilities so that non-engineering stakeholders can go there as well and get an overview of like, what's the health of our system for all past tests or failed tests or whatever. So it's very easy to answer questions, for example, like how many flaky tests we have at Gradle Enterprise in the last 6 months. Well, okay, enough about the repository. You're running the test on CI. Can you also integrate Gradle Enterprise with your CI, and could that be useful? Yeah, sure you can. So This is an example of a build scan here, and as I mentioned before, tags are super important to be able to correlate and split, slice and dice the information you get from the build scans. So here on the top you see the tags that we have on this specific build scan. I'm adding a tag, for example, to mark builds that are run on CI versus on local machines. I'm adding a tag with actually the specific type of device, because sometimes your tests will fail on foldable devices, or maybe on big screens, or on tablets, or maybe on this like small device, or maybe with Android 7, or maybe, oh my God, there are so many variants, right? We also have a tag that we add for our runners on the cloud, because sometimes the machines that we run on AWS or whatever cloud provider you use, they need a little bit more power, or they need a little bit more memory. Or maybe you're running them locally and you need to upgrade your MacBooks for the latest Intel processor. Yeah, so it becomes really easy with the Gradle Enterprise API to define how flakiness compares across CI jobs versus your local jobs, and also across individual engineers in your team, right? By using properly tagging, creating a taxonomy internally, and make sure that you send these tags into Gradle Enterprise. And that becomes exposed later on the Gradle Enterprise API for you to query. Yeah, you can also make your CI smarter, right? Who runs tests multiple times when they start failing? I certainly did that in the past, right? But what's the problem with this? Well, something like the shampoo rule, or maybe like repeated test annotation that appeared in JUnit 5 and JUnit Jupyter, is something that you actually hard code in your repository, right? So a test will be repeated 3 times or 5 times or 10 times. It doesn't matter if the test got more healthy or more unhealthy, it's hard-coded there. And when you check out that commit from a year ago, that's going to repeat again. It's like constant cost. So something we did internally also at Gradle Enterprise was, well, let's query the API, because our API knows what's flaky and what's not, what's healthy now and what's not. So for example, if we have an outage in our backend system, we can dynamically disable some tests. So you can make it smarter and quarantine things by querying the API integrated directly into the CI jobs. So as you can see, the Gradle Enterprise API has a lot of cool use cases, and I think the sky's the limit, especially when it comes to the new test API. So if you're interested to get access to the Gradle Enterprise Test API beta, reach out to us after the talk. Yeah. With just a little caveat as well, if you want to import your instrumentation test, the Android instrumentation test into Gradle Enterprise, come talk to us as well. There's a little script, code snippet that we prepared so that you can import your Android instrumentation test directly into Gradle Enterprise to make them available for the Gradle Enterprise API as well. Beta.
Thanks. I wanted to talk. Hello?
Yeah, there you go.
Yeah. I wanted to talk about one more build cache miss. No, I'm just kidding. Artifact transforms are a really very popularly used feature in Android builds especially. And yeah, before I dive into this topic, let's talk a little bit about what artifact transforms are. So it's a concept from dependency management. What it allows you to do is it changes a dependency from the incorrect format to the format requested. And that's called an artifact transform. An example of this would be transforming a jar into a DEX file, or transforming a jar file back into class files, or something like that. Users or tasks don't directly request transforms, but Gradle will automatically schedule transforms that are registered between units of work when it knows that a specific dependency can be transformed. And another thing, transforms can depend on other tasks, and they can also depend on other transforms, which means you can have chains of artifact transformations in your build. And what I'm very excited to announce to all of you is that artifact transforms are now visible in build scans. This is one of the most commonly requested features by Android developers, and we're super excited. Just a caveat, you have to be using Gradle Enterprise 2023.1 or higher, the Gradle Enterprise plugin 3.13 or higher, as well as Gradle Build Tool 8.1 or higher. And for now, it only visualizes project artifact transformations, but we're working on adding more and improving the feature. So what does this give you? In the build scan, you'll be able to see right next to the tasks, transforms. And this is what they look like. It'll tell you the artifact type, as well as the amount of time that the artifact transform took. You can also click for more details, and when you click for more details, you can see the source and the target of the transformation. In this case, we're looking at an instrumented jars transformation into a DEX file. And you can also see how long that artifact transformation took. So yeah, why is this so awesome? First off, you can understand artifact transform dependencies in your build. It also fills gaps in the timeline that were previously empty. And you can also understand errors that happened with artifact transform. So yeah, just an example here. You can understand dependencies. So when you click on a transform in your timeline, in the same way that if you click on a task in the timeline, you can see dependencies. They're called predecessors in the timeline. And in this case, this artifact transformation had both task dependencies as well as other artifact transform dependencies. What's also cool is that you can see gaps. The gaps are now filled in the timeline. So in this case, all these light gray squares are actually artifact transformations that would previously be empty on the timeline. And in the top right, you can see that this timeline in the build scan is being filtered by transforms. What you can also see is failures for artifact transformation. So for example, this is just an example of artifact transforms that failed. You can click on the Details tab, and then also appears in the Failures tab in Gradle Enterprise. This information would previously basically be not there at all. So yeah, and then you can search for failures in the Failures dashboard in Gradle Enterprise. Yeah, there's also some upcoming work. Right now, you don't see whether transforms are cached or not, as well as you don't see whether the transform was up to date or not. There's several different ways that artifact transforms are cached, and we'll be able to see that in the next version of Gradle Enterprise, as well as the next version of the Gradle build tool. We're also working on improving the transform filter in the timeline, so you can filter by things like, for example, cacheability. And we're also working on adding more transform types, such as the Jetifier transform, which is, I know everyone here's favorite artifact transformation. And with that, that is the end of our presentation.
Oh, that was too fast. Yeah, thank you. Yeah.